Hi there, it's Rich from eTool, and I wanted to demo our new Rapid Lifecycle Assessment app for housing. The app can be accessed via any device with a browser, but specifically also downloaded as an app on Apple and Android devices as well. We deliberately designed it as a mobile app so that it was really portable and really easy to use. And we are hoping that pretty much anybody with a tiny bit of knowledge about building design would be able to use the app to optimize in particular, the carbon footprint of their building. And that's the whole idea: is reducing greenhouse gas impacts. That's our motivation at eTool, and that's why the first page that the user sees is this one here with featured designs. The designs you see on this is a test environment, but it looks like this on the production environment as well. The designs you see on the screen at the moment are display homes at the Witchcliff, or virtual display homes I guess you call them, for the Witchcliff Eco Village in Western Australia. So big shout out to them, first commercial developer using the new app, but also they're doing some wonderful things in terms of low carbon and sustainable design. So check it out. Anyway, users of the app will be able to click through on these designs and see not only the performance. In this case, these are all slightly better than zero carbon. So not only see the performance, but also see the key strategies that enable them to achieve that performance. So it's effectively some inspiration for the users, and hopefully also shift the social norm so people can see that when there's hundreds of these designs in here that are getting really low carbon or zero carbon results, people know that there's it's not as hard as some would have us believe. So first thing we need to do, what I want to do now is demo actually doing an LCA. So what we need to do is pinpoint where the development is. That's going to tell us what the climate's like, which will affect the heating and cooling loads and hot water energy, etc. But also what grid the building's connected to. That has obviously a big effect on the operational energy impacts, and similarly what water grid as well. So we'll put a suburb in here, and it'll bring up any pre-configured developments, so land developments or government authority areas that are within 50 kilometres of that suburb. If the appropriate item doesn't come up for you, you can add a new development. But I'm going to run through an example project within the City of Vincent. City of Vincent has some great sustainability targets for all new homes in their latest building policy, and we're piloting the use of the app for meeting those targets for or demonstrating those targets for low density residential buildings. There's a few different ways that government authorities or developers can configure the app. I won't go into detail, but the normal way a land development would be configured is all the lots would be loaded up prior, and they'd all be prepaid. For government authorities, it may be they may be prepaid. Unlikely that all the lots will be uploaded prior, because there's a lot of subdivision and things that happens in that planning space. So the lots don't even exist at any point in time. So before the DA, so it's more likely that they won't have pre-configured lots, and they may or may not be prepaid depending on how the local government or the government authority wants to run this. So in this case, it's not pre-configured, not prepaid. So what I'm going to do is create my lot. I'm going to give it an address and a description, and then I'll start designing. Now, what the app does initially is it loads up a pre-configured base design, which is, in this case, we agreed on this base design with the government authority. If it's a land development, we'd agree on that with the developer. We'll also give the land people building in land developments the ability to load up a pre-configured display home, for example, display home design. So those builders that are contributing to the display village, their design should be available for users to select. And then what we can do is we can start actually, where are we? We can actually start we can add a little picture of our design in here, and we can start reconfiguring these settings so that they match our design. So let's assume we've got a three bedroom home with 2 car parks, but it's a carport, and it's a 2-story building. Maybe we've got higher floor areas. Now, as I'm changing things, what's actually happening under the hood is the wall areas, floor areas, upper floor, lower floor, roof area, etc. is all being updated based on these simple inputs. We can customize that in more detail later, but what we're doing here is getting a basic estimate of the takeoff of all our components with a very small amount of data or user input. And what I'm going to do is customize things a little bit more. I've got a heap of building attributes. Some of these are a bit of a deep dive, but are necessary because there might be some kind of feedback loop. For example, the water, all our water use needs to be decided pretty well up front, because all our fixtures and fittings, because there's the amount of water available for a grey water system to then supply back to irrigation water, for example, relies on understanding how much water is going to be used in the building. So so that's one of the areas we need to deep dive a bit on here. But now, if the users don't know what these things mean, they can hit this little information button, for example, energy monitoring, and we can see here it's a device that enables designers to nudge occupant behaviour by giving the occupants feedback on their energy use, and it goes into more detail. So there's information here to help the users navigate through this and understand what we're talking about. But otherwise, the designer or owner builder or salesperson, whoever's using the app, can just run through here and select the appropriate settings. And I'm going to go for what I believe is a fairly good performing design. It's not it's not overreaching. It's definitely something that's fairly easy to achieve, and it wouldn't probably wouldn't impact the capital costs very much. But we're going to see how low carbon we can get with these selections that I'm putting in through now. So I'm going to go through this pretty quickly because it is a demo, but I will at points try and explain things. So I've just I've finished this first page. I'm now going to customize things further. I can look at integrated services such as the stove, the water tank, the hot water system, etc. I'm going to make this an all electric building. So I'm going to change this to an induction stove, and I'm going to change my gas hot water system to a high efficiency heat pump with a CO2 refrigerant. I'll leave all this the same because we might show you how you can further optimize once we've got our initial results. There's not a lot we can change on the plug load screen in this particular development because this government authority wanted to lock this down pretty much. We can change the size and the level of ventilation in the fridge recess, the primary fridge recess, which will sort of move the needle a little bit on your refrigeration energy. But we can't change any of the TVs or anything. We're just assuming average, in this case Australian average. I'm going to get rid of the pool here. We'll have an ability to delete at the moment. I just need to set it to essentially 0. And I'm going to add a decent size solar system here. This is a great climate for solar PV, so we'll definitely make use of that. It should make the performance, all else being equal, it'll give it a good bump in the right direction. We can change things. We can change the structural components as well. For example, I might go for a high fly ash floor. So we've got really high fly ash. These are 90% fly ash. Thought I had some other selections in there. As well. Oh yeah, there is ground granulated blast furnace slag as well, so a 40% selection in here. So I may as well go for the really high fly ash one. So this is a geopolymer, not very common, but definitely definitely getting a little bit of little bit more common. What I might also do for my upper floor area, I might change this to a timber floor. Oops, maybe CLT if I've got any. Not sure that we do. Don't have CLT. That's a component we'll have to add. So you can add components in fairly easily. It's an admin task, but that's something that we can fairly easily add components as well. So I'll just go for a normal elevated timber floor with bearers and joists, and I'll change my staircase to timber. I might change my external walls. I might leave the ground floor as double brick, but change the upper floor to a stud wall. So this is a fibre cement clad external wall. And I'll do a similar thing for the internal walls. Okay, we can then customize finishes. At the moment we've only got floor finishes in here. We will be adding wall finishes as well, but I'm going to change these lower floors, the living and dining, assuming that's on the lower floor, to polished concrete. Which should be fairly low impact after that initial grind and polish. And I might change I'll leave the carpet in there and just see if that comes up as one of the bigger remaining impacts. So we'll see where we ended up with our targets. So that's great. We actually ended up with a net zero carbon, a bit better than a net zero carbon global warming potential. I'd say a lot of that is due to that PV system, particularly because it's only a 3-bedroom home, so not a lot of occupants, so large PV system for not a lot of energy demand. But we did change a lot throughout that very quick assessment, and it's pretty cool. I mean, I think we started that assessment at about 12 minutes ago, and we've already got some results out, and I was stopping a little bit to explain things as I went. So you can imagine someone who's had a little bit of practice at this is probably going to be able to fly through these assessments really, really quickly and actually get life cycle assessment results in sort of that 10-minute time frame, which is pretty awesome. So what I can do is drill down into the results. I need to pay for this now, so just ignore the entries here. This is a test environment, so you won't be able to use any of these values. They're just test card numbers if you were tempted. Okay, so yeah, that's succeeded. So I can now drill down into the results to see what was driving the remaining global warming impacts. And I can look at this using different focal points. So focus in on energy. I can see this is that big positive impact of the PV, the solar photovoltaics. And my remaining items are actually, there's a lot of plug loads there, which is pretty hard to influence as a building designer. The cooking is fairly high. Heating, ventilation and cooling is pretty big. So let's have a go at optimizing this a little. So there's a few things we could do here. And actually this would be interesting. If I flick over to materials here for the focal point, I can see that my refrigerant gases are actually pretty big as well. And so I've got the split system air conditioner is coming up in two places in terms of it's coming up as a big hitter in the materials, and it's also coming up as a big hitter in the energy. So it seems like a bit of a no-brainer that, well, it's not huge in the energy, but it's still reasonably significant. So it does seem like a bit of a no-brainer that we should look at alternative heating and cooling services. So I'm going to go with ceiling fans for cooling, which won't require the refrigerants, and I'm going to go for a pellet heater for heating. Okay, so that has dropped the heating, ventilation and air conditioning right down in terms of the impacts. And if I go into the materials, I can see the gases now are right down here. So we've sort of moved the needle a little bit on those particular items. The finish, so the biggest remaining embodied impacts in the materials are the finished products, and I'd say most of that is in the PV. Now the PV itself pays itself off very quickly environmentally, but it still has some significant impacts. So really, really big benefit, and but some impacts as well. So that's why that's showing up here. I should mention as well, so when we drill down into these things and we start looking at these components, we will be ordering these from highest to lowest and putting that bar that tells us, similar to this page here, that tells us how big the relative impacts are. So that'll make it even easier to spot the big hitters. So I've done a little bit of optimization there. I bumped it up by another 3%, making those little changes there. I'm also hitting my target on the water. So this one's ready to submit. When I'm submitting, there's a few things that are going on here. So in the case of a land developer who's using this app to manage the carbon footprint of their development, they're going to then get visibility of that submitted design. There may even be a workflow that requires you to add some other documentation, and that's part of the actual approval process for your design on their land development. For local government authorities or government authorities, sort of more generally, I guess, it'll put the design, and actually it'll do this for the land developments as well. It'll put the design in a sort of locked state, and it'll generate some automated reports for you, and everybody should have some sort of access to a summary on the internet, so that they can see the key performance of the projects and what drove that performance. But it'll be locked down until such time that the user wants to make some kind of change to the design, and then they'll have to reopen it. That'll communicate that it's under revision to the key stakeholders, and that way we can kind of work through those different stages of a design over its life cycle. So I'm just going to submit it now, and I'll just demo one report. So this is the first report that we've delivered through the app, and it was specifically for the City of Vincent, but there's a whole bunch that are also about to come in releases, upcoming releases. So it's the compliance checklist report. This will be useful for both government authorities and land developers, because it enables them to see not only the performance of the building, but also gives them some insights into how the performance was achieved. So I've done something to the size of my viewpoint here. Sorry, everyone. Here it is. Okay, so it gives us our performance against the targets. There's a table here which also shows us, a bit hard to see, but I'll zoom in here. So the table shows us the performance in these main life cycle stages. So we can see where the design is performing better, and I can see a lot of the savings here are in the integrated energy use. There's a small positive change in the plug loads, also initial material and construction. In the water indicator, because we're measuring water as an environmental performance target in this government authority as well, most of the benefit is in the treatment, but there's also water use, net fresh water use throughout the supply chain in these other modules as well, and you can see they've made some small improvements in these other modules too. Now the other component, the other useful component of this report is highlighting in yellow where the changes were made to achieve these results. So this would give, in the case of a government authority, the planning department or people that may be assessing this, gives them a direct, it sort of highlights immediately what changes were made in order to achieve the results. So they know where to look for evidence of these changes in the other documentation. Just done it again. Sorry about that. Okay, so that's just an example report. I delved into that in probably a little bit too much detail, but there'll be other reports like a sort of summary design rating, a really detailed life cycle assessment report, a greenhouse gas savings summary. There'll probably be further reports as well. And there'll also be this ability to share the design on, so create a shareable link, which will be a really nice summary page of the design performance, which is hopefully, again, quite shareable so that people can share their good performance and inspire other people to build low carbon homes. And you've got to share those on those different social platforms and yeah, hopefully drive that change. So I won't demo it, but the key for this demo was just to really focus on the speed with which you can conduct a life cycle assessment. There'll also be a full portal for property developers and government authorities to see the whole portfolio of what's happening within their within their land development or their jurisdiction, whatever it might be. So it'll have summary carbon savings or summary indicator savings for those other environmental indicators. You'll be able to see who the participants are, who's submitting the reports, at what stage the different reports are at, because we might have different hurdles in terms of planning and building license, etc. So that should all be visible on that government authority or developer portal where they can kind of manage the portfolio. And as I said, I think there's also potential there that the tool might be used as a method of submitting for some of those stages, some of those. So you might be able to, before you submit, you might actually upload some other documentation that's required for the submission. So that's a possibility as well that we've sort of spoken briefly about with some of the interested parties. Anyway, we'll probably, once we've got some of that built out a little bit more, we'll probably run another demo video on that. But for now, I just wanted to really demonstrate how easy it is to conduct an LCA in this new app. Cheers.